Everybody, let's try this problem. So we have a skier with some initial speed, then goes up this high rise, and then we want to know the final speed. Okay, so now there is friction. So there is work being done by friction, kind of messing up our conservation of energy. Okay, how much is this though? Work, let me write it over here on the side. Work by friction. So the skier is going up the ramp. So if the ramp is like this, friction is going this way. And then the skier's displacement is this way up the ramp. So the work would be this vector dot this vector. So negative this times this, because they're just 180 degrees. If the skier goes some distance d. Okay. And friction is this one. Mu k times n. Right? The coefficient of kinetic friction, normal force. Now, what is the normal force? Let me draw the free body diagram of the skier while she's going up the ramp. Right, so there's kinetic friction, normal force, weight. The skier is going this way. So let's take a look at the geometry. The angle is here, that's 35 degrees. So in the x direction, minus mg sine minus friction, mass times acceleration. The y direction, n minus mg cosine equals mass times acceleration. The skier is going this way in the x direction. There's no motion in the y direction. So ay is 0. If you look at this, that means n equals mg cosine theta. That goes right there. Right, so then this is minus mu k mg cosine theta times d. Alright, d cosine theta. So we have an expression for the work by friction right here. That's right here. Okay. Do we know d? Let's look at the little triangle over here. This is d. This is h. This is theta. So we don't know d. We know theta is 35 degrees. We know h is 2.5 meters. So what's d? Look at the triangle. Sine is opposite over hypotenuse, which means d is h over sine theta. So I should put that substitution right here. mgd, which is h over sine theta times cosine theta. So let me change that right here, right? So this is h cotangent. I'll just write h over tangent. Okay, so we got an expression for the work by friction, and we know all of those numbers, right? We got the angle, we know h, we know the mass, we know the coefficient of friction is right here, 0.8. Okay, so what's the energy here? The skier is going this fast, so there's kinetic energy, V initial. I'll just write VI for initial. Gravitational potential energy depends where we pick the datum. So how about we pick the datum right here? So initially the skier is at the datum, so no gravitational potential energy. Okay, and then when the skier is up here, going this fast, 1/2 mv final squared. And now the skier is above the datum by h, 2.5 meters. Okay, now let's take a look at what we know and what we don't know. We know yes, 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 Yes. We got the angle, initial speed, 12. Final speed, we don't know. That's actually what we're looking for. And there we go. Okay, so then, and I also already noticed that we can divide everything by something that's non-zero. So it's interesting, the mass of the skier factored out of there, right? And then just solve for V final. Just take this, move it on that side, times everything by 2, and then take the square root. Then you got this. Okay, so keep on studying. I'll see you on the next video.